Welcome to episode 4 of the Thinking Behind Reality podcast. Scale changes everything. Reality feels consistent. A meter is a meter. A second is a second. A day is a day. But this sense of consistency is an illusion created by scale. The universe behaves very differently depending on how closely or how broadly you look. At human scale, the world feels stable and predictable. Objects have clear boundaries. Causes lead to effects in familiar ways. Time flows at a comfortable pace. But shrink your perspective down to the scale of atoms, and the rules begin to blur. Particles don't have precise locations. Outcomes become probabilistic. Motion replaces solidity. What felt fixed becomes uncertain. Now zoom out. At the scale of planets and stars, gravity reshapes space itself. Time stretches and slows. Massive objects bend the paths of light. Events that feel instantaneous to us unfold over millions or billions of years. The same universe, different scales, different behavior. This is why intuition often fails us. Our instincts evolved to navigate a narrow middle ground. Human size, human speed, human energy. They were never designed to grasp the very small or the very large. What feels obvious at one scale can be completely misleading at another. Scientific thinking matters because it forces us to abandon scale-based assumptions. It reminds us that truth isn't universal across perspectives. What's accurate in one context may be false in another. A solid object at human scale is mostly empty space at atomic scale. A static sky at human scale is a violent dynamic system at cosmic scale. Scale doesn't just change how things look, it changes what questions make sense. At small scales, we ask about probability and uncertainty. At large scales, we ask about curvature and expansion. At human scales, we ask about purpose and meaning. Each scale reveals a different layer of reality. This layered structure explains why debates about reality often go nowhere. People argue as if one perspective should explain everything. But reality doesn't live at a single scale. It's distributed across many. Scientific thinking teaches us to ask, at what scale does this explanation apply? Once you start thinking this way, contradictions soften. Wave and particle aren't opposites, they're scale-dependent descriptions. Determinism and randomness aren't enemies, they operate in different regimes. Reality isn't inconsistent, it's contextual. Understanding scale doesn't make reality simpler, it makes it more honest. And it sets the stage for a deeper insight. If reality changes its behavior across scales, if structure, time, and certainty shift with perspective, then what exactly persists? What remains real when everything else depends on scale? That question leads us next to something more fundamental than objects: patterns. This is the thinking behind reality. I am glad you are here.